Okay, so ladies and gentlemen, water is leaking out of a container with a hole in the bottom. So Chilly's law states that at any instant, the velocity v with which the water escapes from the container is a power function of d, the depth of the water at that moment. When d equals 1 foot, then the velocity equals 8 feet per second. When d equals 1/4 foot, then the velocity equals 4 feet per second. And we're predicting what p will be. If it'll be a positive integer, a negative integer, or a fraction. We know this is all power functions. Okay, we say p is a fraction because it can't be negative. The water depth will be 0 at one point. At one point will be 0. Correct. Will be 0. Why can't it be positive? Okay, if it was positive, the water would be increasing, not decreasing. If it was positive, the depth would be increasing. Okay, well, you're writing this down because it opened the funky link layer, so it's going to disappear, but we're going to talk about B. Make sure you've got A written down. What is the value of A and how you know? So we know our equation has to look something like y equals A times x to the p, where p is the power. And in this case, instead of y and x, we're using velocity equals A times the depth to some p. So there are two different ways to find A. How have we found A in the past? Anybody remember? That's the vertex. You're finding vertexes. They don't want to know the vertex. They want to know what the value of A is. There's two different ways. Yes? You could do that, but what if we don't know what anything else is? How do we find A before? If I give you a table, how do you find A? Okay, so you have to find the differences. But this is to the 1/2. Did that work out for us when we took fraction powers? Did we find A from the table? From the second differences? No. Where was A located? So anybody got their station sheet out in front of them? Their station packet for when we took when we did powers to the fractions. So I believe that was station 3. So you answered that question at the end. How do we find A? When x equals 1. Do we have one up here where x equals 1? So let's look at our 2 points. We've got point 1,8 and point 1,44. So what is A? When x is 1, A would be 8. Sorry that this is disappearing. Okay, so the A value, A equals 8, because we plug in 1,8 into the formula. B equals A times D to the P. Okay, so we get 8 equals A times 1 to the P. And since 1 is raised to a power is 1, the equation requires us to find that A equals 8. All right. Using your A value in an ordered pair, we're going to determine what the power is. So we've got what A is. So let's think again. We've got this function right here. We've got the velocity equals A times D to the P. So I'm now going to write the velocity equals 8 times D to the P. But I had another number. What was my other point that I had? I had D equals 1 foot and 8 feet per second, and I had D equals 1/4 foot, and velocity equals 4 feet per second. So I'm just going to plug these in. All right. Well, I can't do anything with 1/4 because I don't know what P is. and I have to do exponent stuff first. Can I move anything else around? How am I going to get p by itself here? Divide 8, good. Can't square root because we don't know that that's squared. So we get 1/2 equals 1/4 to the p. All right, we know p is a what? Fraction. Yes, fraction. So, in your calculator, you're going to type in this because we're going to have to do a guess and check kind of a thing. In your calculator, you're going to put parentheses, 1, divide, 4, parentheses. You're going to put the caret, and then you're going to plug in different fractions in there until you come up with 1/2. So let's try it, Aaron. Come on. Turn into your calculator. Pull up calculate. Yes. Turn it on. Go to the calculator page. Go parentheses, 1 divided by 4. End parentheses, caret button. And then what fraction can you plug in there? When you know it, that's great. Put your hands down. I want everybody to try it.
What we got that last thing?
Yep, that's a division sign. Hey, now you have not plugged anything in there. You have to try a fraction. You have to try a fraction. We're working on focus. We're trying some fraction, and we want to come up with 1/2 as our answer.
I'm sorry, let me see.
Get up. Focus. You have not figured it out yet, Zayla. Zayla. That is not 1/2, so you have to try a different one. So you're plugging in, taking it to different powers until you find it equals 1/2. So you're taking 1/4 to different fraction powers till you find 1/2. So guess it. What do you think?
I got it.
What is it, Bella? 1/2. So we know our equation is velocity equals 8 times d to the 1/2. We found our equation. All right, now that we have this equation, what will the velocity be if the water is 10 feet deep? What do we plug in and where do we plug it in? Good, do it. What do you get?
Are you making us do the back by ourselves?
Will you get 40? Oh,
You do not get 40. Try it again. 8 times 10. Make sure you're raising 10 to the 1/2 power. I don't know why I put 1.
I got it.
Are you making us do the back by ourselves?
No. Keyshawn, I'm ignoring you because I'm doing this first.
It's 14.2.
No, it's not.
What? You
Yes,
shut up.
it is. Yeah, let's see how you're putting this in your calculator, Bill.
What?
So you
You
put,
me.
you raised it to the 1/4 and you just put it to the 1/2.
You shut up.
Shh. Be nice to each other.
Tell him to
Be
shut
nice to each other and please stop talking. So the velocity is what, ladies and gentlemen? Yeah, let's leave it at 25.29, and that's feet per second. Okay. So, what are you going to do with number 2? Because I've already explained this to you. What are you doing with number 2? Skipping it, correct. So we turn to 3 and 4, which we are going to do what? On our own. Okay. Let's read over number 3 so we understand. Below an unlabeled graph of a power function is shown. Obviously, the graph isn't shown there. I'm not sure what happened. If you learn that the point -1, 3 lies on the graph, do you have enough information to write a formula? Yes or no, and tell me why. B, if you learn that the point 1, -3 also lies on the graph, can you figure out what? What new deductions can you make from that? What new things do you know?
Wait, Miss Percy. So what's basically the formula?
You're raising it to a power. If you don't know what the formula is, that's the whole point. Some power function. So C, if we know that point 2, negative 96 lies on the graph, you have 3 points now, negative 1, 3, 1, negative 3, and 2, negative 96. Can you figure out what the function is, and then find 3 more values? Plug in 3 more numbers for X and come out with numbers for Y. Number 4. 2 oil tankers crash in the Pacific Ocean. The spreading oil slick has a circular shape, and the radius of the circle is increasing at 200 meters per hour. So what do you think the kind of power function this is going to be? Is it going to be increasing, decreasing, or can it never be 0? It is. Is the oil slick getting bigger? So it's increasing. Okay? So it's not an appropriate thing to say, especially that you're being recorded right now. Increasing. It is increasing. So we know the power function is going to be positive. So you're going to have to figure out what it is when it's positive. Okay? You're going to express the radius of the spill R as a power function of t time in hours since the crash occurred. You're going to figure out what P is. Okay? And then it has you do something with the formula for the area of a circle. Area of a circle is pi r squared. It's on your paper and it's on the board. Pi can be written as pi or the funky pi symbol. Pi symbol is on your paper. So you're going to find out what P is and Y. Then you're going to express the area of the spill A as a function of time using this formula. So you're going to figure out how to do this. Then you're going to clean up cannot be arranged until 7 hours after crash occurs. How large is the area going to be covered by the oil by then? How big will it be? All right. So, ladies and gentlemen, I'm going to leave the rest to you. If you have questions, feel free to ask them. But if you don't finish this by the end of the hour, it will be homework.